Hello and welcome to Solve Papers channel. My name is Godfrey. In this video, I'm solving Cambridge AS Physics. Topic is Dynamics. October-November 2019 exam series. I encourage you to consider doing your revision topic-wise as you wait for your examination. Read a given topic, and when the content is fresh in your mind, come attempt questions that will be set on that particular topic for several years, 2019, 2018, going backwards. In this way, you should be sure you're going to understand the questions, and you will be able to figure out the areas that are frequently tested by the examiners. This is a sure way of getting your A star. Well, let's get started. Before we get started, if you have not already subscribed to my channel, please click the subscribe button and hit the bell icon below. This way you will be notified every time I upload a new video. Question number 1. And in every question you'll be finding this writing here. It tells you the paper the question was set and what number the question was. Of course, this is October 2019. So this was paper 1-1, and question was number 6. So let's get started. The velocity time graph for an object of mass 2.5 kilogram is shown. The velocity time graph, okay, is velocity on the y-axis, time is on the x-axis. What is the resultant force? What is the resultant force acting on the object? Of course, you know that resultant force, which we basically call force, it's always a resultant. Resultant force is equals to mass times acceleration, right? In this case, since it's a velocity time graph, we can get the acceleration from the gradient. Of course, you know that acceleration is equals to gradient in a velocity time graph. So our resultant force therefore will be equal to mass times gradient, because gradient is equal to acceleration. So can get the gradient. Gradient in this case is equals to, of course, you can pick 2 points. Can pick this point here. This is 3, 0, 3. And I'll get this other point here. This is 15, 12. So then I'll have 12 minus 3 over 15 minus 0. This will give me 0.6 meters per second squared. That's the gradient. So our resultant force will be the mass, which is given here, 2.5 kilograms, times acceleration 0.6 meters per second squared. When you do the multiplication, you get a 1.5 newtons, a force of 1.5 newton. You'll find the answer is right here, C. Number 2. Number 2 was from paper 1-1. This was question number 7. Which statement follows directly from Newton's first law? Newton's first law. What does Newton's first law state? That a body remains in rest or continues in constant speed in a straight line unless acted upon by an external force. So let's look at A. A body remains at constant speed unless acted upon by a resultant force. That is correct. A satellite in circular motion about the Earth has a constant velocity. Yeah, it has a constant velocity, but is in circular motion, so it's accelerating. So if it's accelerating, then you cannot say it has got a constant velocity. Of course, it might be doing a speed of, let's say, 3 meters per second around the circular path. but the direction is changing. You remember that velocity has got both size and direction. So if this is constant and this is changing, then it is the body is accelerating. If this is constant, like in the case of a straight line, and the size is changing, then it is still also accelerating. So it is accelerating, it's not continuing in a constant speed. And according to first law of Newton, then it needs to be either at rest or continue in constant speed. So B is not right. C, a water drop leaving or spinning umbrella travels at a constant velocity. Of course, a water drop leaving a spinning umbrella travels at a constant velocity. That is true, but of course it is acted upon by gravity, so it is accelerated downwards. So that is not also correct. The force acting on an object is equal to its change in momentum. This is not correct, because we know that force is equals to mv minus mu over t, right? So it is force acting on an object is equal to the rate of change of momentum, not the change of momentum. This is the change in momentum. But you can see it is divided by time, so force is not equal to change in momentum. What is equal to change in momentum is impulse. Ft is equals to mv minus mu. This is change in momentum, so this is impulse, and therefore is not force. This is impulse, so this is not right. So the correct answer is A. Number 3. It's great you're watching this video. I encourage you to practice working out this question yourself. You may get these same questions that this same paper, dynamics, that I'm working out at this site, softpapers.co.uk, and the site I'm talking about is this one here. This is the site I'm talking about, softpapers.co.uk. You'll come here. Of course, you can get both math and physics. You can come to physics. Several years. We are on 2019 AS. You come here, click this one, and therefore you'll be taken to this page here. Yeah, we are doing dynamics. This one here. I need you to download this one. Of course, you can get for both November and June. November is multiple and structured. June is still multiple and structured. We are on November. Come and download this here. You can get the rest, both November and June for 2019, 2018, 2017. And of course, you can click here, this green button here, and it will bring you to this page. Of course, you can request your parents to get you these papers. Of course, you're doing this is A2. We are on AS. We have AS structured and we have AS multiple choice. I need you to get this paper. You can click this to add to the cart. It's basically £10. That's a reasonable price for you to get all the all the topical questions. Then, of course, you can get also for June. Get as many as you can, and let's practice. It's a small price to pay to get your A star assured. I also do online tuitions. I'd like to mention this. I also do online tuition. Of course, I would like to help you if you need my assistance. I've helped a lot of students. So if you need my assistance, get me at this site, spacademy.co.uk. If you are only one student, I usually charge £35 per hour if you're only one. But if you come 4 of you, 4 students, I'll give you a fair price of 25 pounds per hour. So check me out on this site, SP Academy. I need you to come to this site. This is the site I'm talking about. You can check out step-by-step student guide here. If you're a tutor, do the same. Then you can watch this video to get familiar with the online live classes. So once you're satisfied and you need my help, I need you to register. Of course, you create your own account, and from your dashboard, then you can, of course, you'll register and then sign in to get to your dashboard. Then from your dashboard, you can find a tutor. My name is Godfrey. You can get me and I will be able to help you out. And let's secure that outstanding grade that you so desire in physics and also in chemistry if you are also doing chemistry. Great. That is out of the way. Let's continue to question number 3. Question number 3. A resultant force causes an object to accelerate. Right, that's obvious. If there's no resultant force, the object travels at constant speed. What is equal to the resultant force? What is equal to the resultant force? Of course, we know that resultant force is equals to mass times acceleration. And of course, we know that mass times change in rate of change of velocity. This is u. Initial velocity minus final velocity minus initial velocity divided by t. That is acceleration. And of course, you can open the brackets and get mv minus mu over t. This is change in momentum. Change in momentum. P is momentum. So the whole of this is the rate of change of momentum. So let's see what is equal to the resultant force. The acceleration of the object per unit mass. The force cannot be that. What A is saying force is equals to A over m. That is not correct. The change in kinetic energy of the object per unit mass. What B is saying is that resultant force is equals to kinetic energy divided by time. This is not correct. That is not correct. There's no quantity called that. C, the change in momentum of the object per unit time. Change in momentum per unit time. This is straightforward correct. Of course, D is wrong. The change in velocity of the object per unit time. They say force is equals to velocity over time. This is outright wrong. So that's why C is correct. Let's go to part number 4. Number 4 is from paper 1-1. It was question number 9. A skydiver falls from an aircraft that is moving horizontally. The vertical component of the velocity of the skydiver is v, and the vertical component of the acceleration of the skydiver is a. Which rho describes v during the first few seconds and after the skydiver leaves the aircraft? Okay, we know that the skydiver attains terminal velocity at some time. Therefore, you can always visualize this graph when you talk about a skydiver. You can always think of this graph. Okay, here we have velocity in meters per second, and this is time in seconds. And of course, the graph usually looks like this. Looks like that. So this is increasing velocity but decreasing acceleration around here. I can draw this one rightly this way. At this point, the velocity is increasing, but you can see the graph is kind of curving, so it's the acceleration is decreasing, and at this point, acceleration is equals to 0. Of course, this is a constant speed at this point. When the acceleration is equals to 0, at this point, acceleration is equals to 0. So at this point, the velocity is constant, it's not changing. And therefore, of course, when the parachute is on, this is the point the parachute comes on, then of course the speed decreases rapidly and attains another terminal velocity at a lower speed. So which row describes V? Which row describes V? V is constant after a few seconds. So V is not constant. V is actually increasing. So it is not constant. A and B are out. And what is happening to acceleration? You can see the acceleration is decreasing until it is 0. So acceleration is not constant. Acceleration is decreasing. So the answer is B, is D. Right there. Number 5. Number 5. This was question 1-1 and it was number 10. Okay. Two gliders are traveling towards each other on a horizontal air track. Air track has got is viewed to be frictionless. Glider P, this one, has a mass of this 0.30 kilogram and is moving with a constant speed of 1.2 meters per second, indicated there. Glider Q, mass 0.6, moving with a constant speed of this. Gliders have perfectly elastic collision. Kinetic energy is conserved, right? What are the speeds of the two gliders after collision? Now, to answer this question, you always think in terms of relative speeds. Relative speed is if you are traveling on glider P, how will and you look at glider Q, how will be this? How will the speed of Q appear to you? And of course, we know that relative speeds, relative speed of approach, approach for elastic collision is always equal to relative speed of separation. When they collide and separate, the speeds are supposed to be the same. And therefore, if we assume this is speed u1 and this is u2 before collision, and after collision, then we have v1 for Q, for P, and we have V, let me call this one VP and VQ after collision. Okay, so then the relative speed of approach will be U1 minus U2, because of course these are speeds, these are velocity, to take the difference. And of course, if U is positive, then U2 is negative, because the directions are opposite. And this should be equal to the relative speed of separation, which is V1 minus, VP minus VQ, because they are moving in opposite direction. Of course, you find that this is U1, negative and negative is plus, U2 is equals to V plus VQ. And in this case, the speed of U1 is 1.2 meters per second, plus, of course, 1.8. This should be equal to VP plus VQ. Of course, this is 3.0 is equals to VP plus VQ. When you add speed of P and final speed of V and final speed of Q after collision, they should be equal to 3.0. Okay, so that was what you look at here. The speed of P and speed of Q after collision. For air, 1.2 plus 1.6 and 0.6. This is 1.8. It is not equal to 3.0. 3.1, so that is not right. B, speed of Q and speed of P and speed of Q after collision. This will give us 2 plus 1 point that give us 3.4 meters per second, which is not right because we need 3. And then of course after the speed at C, 2.8 plus 0.2, this will give us this will be equal to 3.0 meters per second. This should be correct. Let's confirm with D, 3.6, and this will be 4.2 meters per second. So this is wrong. So the answer is D. The answer is C, because we need the speed of P, the final speed of P and final speed of Q after collision to be equal to 30, because relative speed of approach is equal to relative speed of separation, and therefore C is correct. Number 6. Of course, this was paper 1-2 and question number 7. A snooker ball has a mass of 200 grams. It hits the cushion of a snooker table and rebounds along its original path. Okay, it goes back the way it came. The ball arrives at the cushion at the speed of 14 meters per second and leaves the cushion with the speed of 7 meters per second. The ball and the cushion are in contact for 0.6 second. What is the average force exerted on the ball by the cushion? Of course, we know that force is equals to change in momentum over time. Okay, so in this case, you can factor out M. So M is equals to V minus U over T. Okay, so M is 0.2. We change this one into, change 2 grams into kilograms to be 0.2 kilogram. So it will be 0.2 times the final speed of the ball, which is 7, but in the opposite direction. So since it is it has rebound along its original path, if 14 is positive, then 7 is negative. So minus 7 minus the initial velocity, which is 14, minus 14. Okay, and all over this is divided by the time the snooker ball is in contact with the ball, and of course when you do your calculation, you'll find out this is 7.0 newtons. Remember, a vector speed is a vector. That's why we have taken for the final velocity, which is 7 meters per second, you take it to be negative, therefore you get 7. So the right answer here is D. All right. Number 7 was from paper 1-2. Paper 1-2, question number 9. Remember, this is dynamics. The space probe Rosetta was designed to investigate a comet. The probe consisted of an orbiter and a lander. Okay, this is an orbiter, and the lander is this one. Okay, the orbiter has a mass of 170 kilogram, and the lander has a mass of 100 kilogram. When the two parts separated, the lander was pushed towards the surface of the comet, so that its change in velocity towards the comet was 3 meters per second. Okay. Assume, because 3 meters per second is indicated here, assume that the orbiter and the lander were an isolated system, did not influence each other. The orbiter moved away from the comet during the separation. This one went away from the comet. What was the change in speed of the orbiter? What was the change in speed of the orbiter? Of course, for you to solve this question, view it as an explosion. So this is like an explosion. This is like this is like an explosion. Okay, initially for an explosion, everything is at speed 0, and of course in an explosion momentum is conserved. This is like an explosion scenario. Okay, so we know that momentum is conserved. So momentum before, P is for momentum, let me use lowercase p, P before, momentum before is equals to momentum after the explosion. After the explosion. Okay, so momentum before we know is 0. Momentum before the explosion is equals to 0. So therefore, then we know that 0 is equals to momentum after explosion. Okay, and we know that momentum after explosion is equals to 170 times v, okay, which we do not know, plus 100 times 3. But since they are moving in opposite direction, we are told that the orbiter moved away from the comet during the separation. So this orbiter should move away. Therefore, they are in opposite direction. Therefore, if v is positive, then 3 meters per second should be negative times minus 3. Therefore, this gives us 170 v minus 300. Okay, so of course you make v subject, you'll get 170 v is equals to 300. You take 300 that side, v is equals to 300 divided by 170, and this should give you 1.76 meters per second, approximately in 2SF 1.8 meters per second, and therefore the answer is right here, A. Question number 8. Question number 8. A box rests on the earth as shown. This is the box right here. Rests on the earth as shown. Newton's third law describes how forces of the same type act in pairs. One of the force of a pair is the weight of the box. Which arrow represents the other force of the pair? The other force of the pair. Remember, Newton's third law describes how forces of the same type act in pairs. So, of course, we know that from Newton's third law, forces act on different objects and have equal size, are opposite, are of the same type. All right. So, what is W? W is due to gravity. Is due to gravity. Is due to gravity. This W here is due to gravity from the Earth. Gravity is from the Earth. On the box. On the box. All right. What is B? What is this force here? B is contact force. Contact force from the Earth. Okay, from the Earth on the box. Then what is what is air? We have another force here, air. Now air is due to gravity, from the box on the earth. The box is pulling towards, the box is pulling the earth towards itself. All right, and W and air happens to be the same type of forces. W acts on the man, and air acts on the earth, and so are on different objects, right? And according to Newton's third law, this pair of forces, according to Newton's third law, they act on different objects. So W is acting on the box, and air is acting on the earth, right? So W and air are same type of force. They are due to gravity, right? And W acts on the box, and air acts on the earth. Air acts on the earth, and so they act on different objects. So the correct answer here is air. Yeah, which arrow represents the other pair of force? We are given one pair, which is W. So the other pair of force is air. So that is the correct answer right there. Number 9. A snowflake is falling from the sky on a still day. Still day means there is no air blowing. Its weight acts vertically downwards, and air resistance acts vertically upwards. As the snowflake falls, air resistance increases until it is equal to the weight, and there is no resultant force acting on the snowflake at that point. Right? The air resistance is equal to the weight. When the forces become equal, which statement is correct? The snowflakes accelerate. This is not correct. When the force becomes equal, then the resultant force is equals to 0. And when the resultant force is equals to 0, acceleration likewise is equals to 0. But remember, resultant force is equals to mass times acceleration. Therefore, mass cannot become 0. So when resultant force is equals to 0, it is the acceleration which has become 0. Right? Acceleration is not accelerating. So then snowflake is not accelerating. So that is not wrong. That's not correct. The snowflake is decelerating. That is the same as acceleration. That's not correct. The snowflake is stationary. It is moving. It is not stationary. Okay. You can see, of course, it is falling down at a constant speed. The snowflake moves at a constant speed. Correct answer here is D. Very well. Number 10. 10 was from paper 1-3. This was question number 9. Two objects, X and Y, in an isolated system undergo a perfect elastic collision. The velocities of the objects before and after collisions are shown. Before is this, after collision is this. What is the speed v of y after collision? All right. In a perfect collision, in a perfect elastic collision, we know that relative speed of approach is equals to relative speed of separation. and therefore the relative speed of approach here is 20, is equals to 20 minus 12. They are going the same direction, and therefore you take the difference. It's like you are riding in car X and car Y is in front of you. Then how does the speed of car Y appear to you? You're moving faster, so you take the difference. So 20 minus 12 is equals to, of course, 10 minus V, alright? Or you can take it the other way around, V minus 10. Doesn't matter. You just subtract one from the other. So this is going to be 8 is equals to V minus 10. Therefore, V is equals to 18 meters per second. Of course, you take 10 minus, you add both sides 10, becomes 18. So the answer is 18. Okay, this is 8, and this is the relative speed of approach is 8, and therefore the relative speed of approach here should be 8. So if this is 10 and this is 18, then the relative speed of separation here will be 18 minus 10, which is 8. The relative speed of approach here, which is 20 minus 12 is 8. So the relative speed of approach is equals to the relative speed of separation, 8. The answer right there. Oh, that's the last question. Question number 10. Oh, that's it, guys, for this paper of dynamics. Get more papers from this site, guys. Topicals. It's always good to go topical wise. You can, of course, once you are comfortable with all the topics, then now you can start giving a shot at full past papers to build speed, right? Remember, multiple choice paper is only 1 hour 15 minutes. You need to develop muscle and speed as well. So thanks a lot for keeping me company. I hope this has been of help to you. Share this with your friends, and hopefully I'll see you in my next video. Cheers.